Hello and welcome to ClearML. In this video, I want to show you how you can create your very own chatbot based on your own data. So for the purpose of the video, we'll be using ClearML's documentation to create a question answering bot. But you can do this with any of your own data if you wanted to. Links to the code are in the description. This is just an example of what we'll be making. So it's called the promptomizer, and this is the UI we'll be making. And you can see here we have several questions. So for example, how to create ClearML credentials, or how does ClearML orchestration and scheduling work? Now, a normal large language model like ChatGPT won't be able to properly answer this because it's doing everything from memory and doesn't actually have access to external information. But if we add our own documentation, it will be able to give a good answer as well as cited sources and tell exactly which pieces of the documentation used to create this answer. So this is what we'll be making today. Let's get started. In this little diagram I made, you can actually see the steps we're going to take in this video. We'll start with using LangChain, which is a very popular new tool that can actually do templating and adds a whole bunch of features on top of things like ChatGPT. We'll use it actually for grounding. And in this case, what I mean with that is these large language models like ChatGPT or Llama or the others, they all are prone to hallucinating, right? They're basically doing everything from memory. So if you ask them questions, for example, in ClearML, they might forget or jumble up specific information and not be very useful. They might lie or hallucinate and give the user not the answer that is truthful, but that does sound correct. So that's quite dangerous. And what you can do against it is called grounding. Essentially, you're using normal tools like a database, for example, to capture the data that might be most relevant for the user's question, and then give that data to the large language model for it to decide if it wants to use that in its answer or not. And by giving these facts, these actually useful documentation pieces to the AI, it's actually much more likely to produce a useful answer. So this is called grounding, and this is what we're going to do with LangChain in the first part of this video. But then, again, it's not out of the box. So even with this cool LangChain trick, not everything is perfect from the first time. So what we then want to do is introduce our users, our humans, in the loop of training and actually close an active training loop. So what we're going to do is using Streamlit, which is a cool little tool that you can use to make front ends, for example, we'll make an intuitive UI. And the UI will be meant as a sort of quality assurance tool, as a way for other people in my team to interact with the model that I'm training or that I'm fine-tuning, or it's not even training. LangChain doesn't actually train a model. It's more fine-tuning the way that the model is presented the information. So we're going to create this intuitive UI so people can actually give us feedback on how well the model is doing, and then we can always make it better. So again, we're then using active learning to do the human in the loop. So we're going to use ChatGPT to interpret the feedback of these users that they give us in the Streamlit UI, and then send it back to ChatGPT to make a better iteration of itself. So this is kind of the meta learning idea that we're going to do in this video. I think it's going to be very, very interesting. And then of course, around all of this, we'll be using ClearML and for tracking and orchestration, right? So ClearML can do a whole bunch of things, and it will essentially allow you to do this iteration, this training, a lot better, a lot smoother, keep track of everything on how you're doing it at scale. So that's where ClearML comes in. All right, so enough about the theory. Let's start with LangChain, with the first part in grounding. So if I jump over here to my LangChain quick start, what you'll see is immediately the first cell is we're going to need API keys, right? So LangChain, essentially what it does is it allows you to script together in smart ways different APIs, right? So one of the APIs could be ChatGPT or any OpenAI model in the future. Another API could be, in this case, for example, the SERP API, which allows you to search on Google, right? Another API could be a calculator or any other external tools. LangChain offers kind of a framework to build these tools and connect them to each other. So that's exactly what we're going to do. First thing I'm going to do is run this cell So now we have our API keys in memory, and then we immediately set up our ClearML task. So in order to be able to experiment and test different kind of configurations, we want to have a ClearML task running at any time, because ClearML is integrated in LangChain, and it will actually keep track of all of the prompts you do, all of the steps you do, all of the actions that the AI takes, so that you can always go back and see what the results were for specific inputs. So this is very, very useful if you're just trying stuff and seeing what works and what doesn't. So you can actually go in LangChain callbacks and get the ClearML callback handler, which is very useful. It's just built into LangChain. So the first thing we're going to do, and you always have to do this if you use ClearML, is you're going to set up a task, right? This is simple, task.init. We'll call it promptomizer because we're optimizing our prompt here. I'll explain more about that later. And then give our task name just quick start. Output URI essentially says all the models that will be uploaded, because we will be uploading models, just upload them to the server. Then you can set up your callback handler. So I'm going to give it a task type of inference. I'm going to give it the project name of LangChain callback demo. I'm going to give it task name LLM, and I'm going to give some tasks. Then you have here's some options. So you can use visualizations. We'll keep that to true because it's nice to see those. You have complexity metrics as well. Those will be very detailed. So I'm not going to include them here to keep things very clear. And also streaming logs, we'll keep that on false because it can clutter quite a bit, but you can always enable those if you're interested. Then we'll make a manager out of those and use those in every single call to LangChain that we'll do. Now, the goal of this notebook is actually to teach you what LangChain does, right? Because in order to fully understand how we can make this documentation answering bot, we'll have to know how LangChain works. So let's start with something simple, right? We can use LangChain's wrapper to get an OpenAI model. So this is the first thing that LangChain offers you is access to these APIs, one of which is OpenAI, sorry. So we're going to define our large language model. We're going to say OpenAI, I want a temperature of 0.9. Essentially, your temperature is between 0 and 1. The higher your temperature, the more it will deviate from what is essentially an average next word, right? So if you have the temperature on 0, it will always deterministically answer with the most likely next word in the chain, right? And so it will generate an answer that is very average. And then if you put that temperature higher, you will get more creative answers, but that are also outside of what is normal and isn't always useful. So it depends on what you want to do, how you want to set this temperature. Then we use the callback manager and set it to our ClearML manager, and then set verbose to true, otherwise it will not actually log to ClearML. This is just how LangChain is built, right? And so let's start with something simple. We have our text here. What would be a good company name for a company that makes colorful socks, right? Something fun to start out with. We'll print what the LLM thinks about that or what the LLM would answer, and then we can use our ClearML callback to flush the tracker. So the reason that we do this is we're in a notebook environment here. So the ClearML task has started, and then if we use flush tracker, it will essentially say, hey, I've now run what I wanted to run. Everything that happened so far, keep that separate. And it will put that into a separate, nice little table. We'll actually see in just a second what that looks like. And it will say colorful comfort socks. And then the ClearML task reports that it has completed the model upload as well. I'll show you in just a minute what that looks like. Now, the goal here again is to create this chatbot, right? To create this bot that can answer questions based on ClearML or about ClearML. So what I want to do is ask some questions about ClearML. How can I get started with ClearML, for example? But this is not actually perfect because, again, it's doing this from memory. It doesn't have any external sources to draw from. It's only trained it up until 2021, so it's not ideal. It will say to get started with ClearML, you can sign up for a free trial or purchase a subscription. That is actually true. But then once you have an account, you can start using ClearML platform to manage your machine learning experiments, track metrics, and learn and deploy models. Also true. You can also use ClearML Python SDK to integrate ClearML into your existing workflow. Also true, but they're not exactly the steps that I would be interested in, right? I would want to know, like if I ask, how can I get started with ClearML? I want like a 1, 2, 3, 4, 5 step instruction on how I can set everything up. This is very broad. It's correct, but it's very broad. And so it's probably going to benefit from some external information from our documentation, right? So before I go any further into the LangChain, I want to show you how the ClearML integration of LangChain works. So go to app.clearml and you'll see that my promptomizer here, I've done this quite a bit so far. You'll see that my promptomizer quick start has a experiment running here. I'll make it a little bit bigger so that you can actually see it and put it full screen. So if I go to the plots here, what you'll see is action records and session analysis. And the cool thing about these tables is that you can actually see the interaction with your large language model on a prompt by answer basis, right? So you can see here, how do I get started with ClearML? And then how to get started with ClearML, blah, blah, blah. This is the output of the model. It will also tell you how much tokens you used and basically what the usage of the OpenAI API was. The subcompany was the other one. So now what would be a good name for the subcompany? Colorful Socks. Right? So this is what ClearML will keep track of for you. You also have in the artifact section, you have the notebook that you were running, you have the subcompany and getting ClearML started, the model configurations here as well, which is what it's actually uploading. So you can always use this data to go back in time and find what worked, what didn't, compare over multiple runs, etc., etc. Right? So this is what that does. If we now go back to our quick start here, you can see prompt customization is the next step in LangChain, right? So prompt customization is actually quite simple. It's essentially saying, I want an input variable, for example, a product, and I want to be able to set that product name dynamically, right? So if I do this, I now have a prompt template, and I can fill in that template with, for example, colorful socks. But I can do anything that I want, right? So I can, for example, say, what is a good name for a company that makes ClearML, right? It's not an ideal sentence, but this now is dynamic, which is very, very handy. Now that we have this dynamic prompt, we can actually start chaining these two together. So we can actually start chaining the prompt that we just made to the model itself, right? So in this case, we'll actually make a new model, OpenAI, with a temperature of 0.6, callback manager, as we've seen before, product, and we actually make our prompt here as well, and then we chain them together. This is where the name LangChain comes from, is now we've chained these two together. And if I do this, let me run these cells real quick. If I do this, I can ask it to run on ethically sourced smartphones. And now it will actually make this prompt, fill it in for you, and then send it to the LLM and give you the result back. So in this case, you'll see the Eco Smartphones would be a cool name. And then we flush the tracker again. So this is just a very quick way that you can see how LangChain works. It allows you to dynamically create prompts and then link them to a large language model. But now we can go even further, right? Because what LangChain thought, okay, if we can do that, we can chain infinitely many steps together, right? So what I think is a really, really cool chain that they made for us, and this is also the power of LangChain, is they've made some chains for us that we can just use out of the box. And then they have all of those prompts, dynamic prompts ready. And the only thing I have to do is like give it an input variable. So this is what we're going to see here. You can actually use it to do math, right? Because remember, the LLMs are not very good at math, right? At least as of the time of this video, ChatGPT is pretty bad at math, but what it is pretty good at is writing code. So what we can do is actually use a prompt that asks ChatGPT, hey, you're going to get a math question. Instead of answering it, create some Python code that can answer this math question. And then we'll just use any normal code interpreter to run this code, and that will give us the correct answer. So this is just like a little hack that LangChain found, and it's all packaged in this neat little chain called LLMOPS, right? So if I run this, what you'll see is we're going to create an OpenAI model with temperature 0. We want it like straight to the point. We want to create our LLMOPS, and then we can run it to say 1 is 13 raised to the 0.3432 power, right? If I run this, what it'll do is it says, what is that power? And instead of giving the answer, it will give me the code to get to the answer, right? And the interesting part comes when I click on this and I go to what the LLMOPS actually does, is it has this prompt that we'll see in just a second. And then, wait, let me go to there first. So we have LLMOPS here, and then there is a prompt here. So essentially, this is the prompt that is pre-made by LangChain. So it says, translate a math problem into Python code that can be executed in Python 3. Then it gives some examples, and then it fills in the question that I am asking, right? So this question right here will be inserted right here. And if I then go back to our math chain itself, you can also see that the output, so the call will just send it through, like fill in the prompt and send it to the LLM. And then you can also see that we process the LLM result. And if we see that any of the results start with Python, or like with a code block for Python, we will actually run it in a Python executor, right? And so this allows us to basically ask the ChatGPT model, or like the GPT model, to output a specific piece of code, and then we can just run it conventionally without any LLM. So this is like just an example of how incredibly strong this chaining idea can be, because you can make this pre-built prompt ahead of time. Right, so now that you know how LangChain works, I want to explain to you how we're going to hack it to optimize itself using a question answering language chain. This is going to be quite complex. I hope you can follow along. If you have any questions, let me know down in the comments below. So this is the overview of what we're going to do. Let's start with the meta prompt. So we're going to ask ChatGPT to create a set of instructions for another ChatGPT model that will be our question answering bot, right? So we're going to, for example, we're going to ask it, give me a good set of instructions for a QA bot based on these examples. In actuality, this will be much more detailed, but this is the essence, right? So what that prompt will give us is a set of instructions, or an instruction. For example, answer the user's questions based on the previous or on the provided sources, right? And then we'll add the user question with this dynamic prompt templating. We'll just add in the question, and we'll also add in any relevant documentation. How we're actually going to do this, I'll explain to you later, but just assume that we have relevant snippets of documentation that we can just add in there. So the total prompt for our question answering bot will be a set of instructions that's generated by another AI, then a number of sources that we get straight from the documentation, and then a question from the user. For example, how can I run ClearML in CPU-only mode, or like a ClearML agent in CPU-only mode? This is going to be the prompt. Then it will give an answer to that prompt, right? Because that's the reason for this question answering bot to exist, is I want to ask it a user question. So we'll sample a user question from some example questions that we know the answers to. We'll give it the prompt, the full detailed instructions plus the documentation plus the example question, and it will give me an answer. For example, let's say, yes, you can do this. This was my source. The source comes obviously from this documentation. Now we're going to serve these example questions together with these answers. So you always have a question and an answer. We'll serve these example questions, this test set of questions, we'll serve this in Streamlit. And if we do this in Streamlit, human labelers, and basically anyone, it could be a QA, like quality assurance team member, it could be a colleague, it could be yourself, anyone would have access to the Streamlit app and would be able to actually rate the quality of the answers given the example questions. Then the human can actually label this with, for example, a score, and then some feedback on how it should improve. Now, this data, this feedback, the score, and how it should improve, we can actually take as a variable and then add to the meta prompt, right? See how we're closing the loop here? So what we're actually doing is, for example, saying, give me a good instruction prompt for a QA bot based on these examples. And then the example would be the instruction set that it gave the round before, together with what score that instruction set received and any human feedback. And we can do this infinitely many times because we have this dynamic prompt, right? Using LangChain. So we can give that, it will generate a new meta prompt. That new meta prompt, using more information, more feedback, will generate a better instruction set for the QA prompt, which will then again get the relevant documentation, get the user question in there, and then again will be served in the Streamlit app in order to again be evaluated and again be iterated upon. So this is the whole chain that we're talking about. This is the Streamlit UI together with the active learning with the human in the loop. This is the essence of today's video. So I want to now dive into the code and show you what that actually looks like. So if I go here into my Visual Studio Code, we'll go through the code of our Streamlit app. And the Streamlit app is here meta optimizing. I'll actually collapse this. This is the essence of today's video. So what we're going to do is we're going to create our meta optimizer class, which is a custom class. I'll explain to you, or to show you what that does in just a second. We'll load the state for later. If we've been doing this iteration for quite a while, it's always useful to get to start where you left off. And these are our testing examples, right? So these are these example questions that will be feeding into the Streamlit app. So if I go back here, then using Streamlit, we're going to create our promptomizer, our title. We're going to set the instructions prompt, right? Because we always want to see what the current version of the instruction set prompt is, right? So this is going to be this prompt. And then, oh, no, not that prompt, sorry. It will be this prompt. These are the instructions. So it will be this one. And then what we'll do is for each of the questions in our example questions, we'll create a question answer block, right? A question answer example block, and then we'll allow the user some feedback and some score that they can generally fill in how they see fit. And then end here. So we also have our button submit feedback. So if I run this, Streamlit run meta optimizing, it should start our Streamlit app right here. Side note, if you're an enterprise user, you can host your Streamlit app right from within ClearML, just like Gragio. You'll get a safely hosted link here that you can share with your colleagues or clients, a preview of the app here, and all of the app's logs here. Streamlit app hosting is only one of the many apps you can use. Check out our website for more information on enterprise pricing. All right, we're back. So what you can see here is, let me make it a little bigger. There we go. So what you can see here is the current version of the instruction prompt. Based on your question, please provide a clear and concise answer with relevant sources. If you are unsure of the answer, kindly state that you do not know. It is crucial to provide accurate information and cite sources to support your answer. So this is the initial prompt, right? The instructions, together with these instructions, we get the relevant documentation and the user question. The first user question is, how do I create ClearML credentials? The answer is like this. So to create ClearML credentials, blah, 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 this looks pretty decent, but then it says sources and then all of these sources, but it's not correctly detected because it wasn't capitalized. And this is kind of stupid, right? It's just a formatting issue, but we'll see that come back as well. So this is actually the first type of feedback that we can give to this system. Then how does ClearML orchestration scheduling works? And it gives us an answer here. Again, the sources aren't properly, like in the proper format, right? So this is kind of feedback that we can give. Same thing here. How can you clone an entire ClearML project? It's actually not possible to do that. You can only clone tasks. So this is also something that is wrong, but the sources are correctly interpreted here. Same thing with question 3, same thing with question 4, and same thing with question 5. So you would go through this. Any person can do this, right? This is the power of having this as a Streamlit application, is any person can give that feedback. So I'll give it a score of maybe 3 out of 5 and say general feedback. Please make sure you report your sources with exactly sources semicolon. right? Using this format will allow us to better format the results. Now, if I add this and click submit, what will happen is we'll actually add this feedback to the meta prompt. So this feedback will be added to here, give me a good instruction prompt for a QA bot based on these examples. And now this is one of the examples, right? So that will be the, let me go all the way up top. That will be this instruction prompt together with the score, together with the feedback. And then it will generate a new question answering prompt that will hopefully have the sources key correct, right? That's the idea. So while that is running, I want to walk you through the code here. Let me get rid of that and show you how this actually works. So I made a meta optimizer class that will do most of the heavy lifting. We'll go through that in just a second. We'll load our previous examples just so we don't lose progress. And these are the example questions that you can see. It's just a list. We can change this however we want. We give it a title, we give it some instruction table. We give, for each of the questions in the list of questions, we can give it a question and an answer block. We give it a feedback subheader with number input score and text area general feedback, right? This is the Streamlit app build that we just saw. But what is interesting, of course, is the Meta Optimizer class. And the Meta Optimizer class has a lot of different things in it. So we'll go one by one. First off, the model name is ChatGPT. It's GPT 3.5 Turbo is the ChatGPT model. Then we define the callback in just the same way as we did in the quick start of LangChain. So this basically allows ClearML to keep track of everything that we're doing here, which is very, very useful in this case, especially because we're doing this iterative process. Then we have our instructions generator, which is our first model, right? This is the meta prompt model. So the instructions generator is a ChatGPT model with 0.7 temperature. Now we also have some examples. So in this case, these examples are the seed examples of possible prompts with their score and some feedback. So these are just ones that I prepared ahead of time so that it doesn't start with an empty prompt, right? So one of the instructions is this: given the following extracted parts of a long document, it's got a score 4 and it's got some comments. Another one is, for example, please explain, which is not nearly detailed enough. So the score here is 0 and the comments is the bot had no idea what it was doing. It probably needs better context and explanation first. So what we're doing here is having some seed examples. This self.examples will be appended with every iteration. So every time we add our feedback, it will be added to these examples. Then we get our documentation. And so our documentation is, I don't want to dive too deep into this, but the documentation is essentially a database with embedded snippets of documentation. And so if you ask it a question, it will actually reply to you, or like it will give you the 4 most likely useful pieces of documentation that are most likely to fit your question. So this is what that does. If you're interested in that specific part, there are some great tutorials and blog posts out there that I'll link in the description below. Then we create our question and answering bot itself. So this is another ChatGPT model with the same model name with only a temperature of 0.2. We want to keep it relatively clean and not too all over the place, right, in answering the questions. Then what we also want to do is embed every time that we do that we create a new instruction set, we want to embed that because then we can visualize that. So that's pretty cool as well. I'll show you that in a minute as well. All right, this is just the initialization. So what then happens is one after the other, we first create the instructions, right? This is the first step right here. We ask this question and it generates a new instruction set for us. So what that looks like is I'm looking for the optimal initial prompt for a documentation QA chatbot. The prompt should instruct the documentation bot on how to best answer the question. Below are examples of prompts as evaluated by a human annotator. This is what we remember. And then example and some extra information. We're essentially asking it to interpolate in an embedding space between the optimal prompts, right? Because we have the score of each, so you want to go further away from the ones that have a lower score, and you want to go closer into the ones that have a higher score. This is super cool. Normally you would do this just in mathematics. And now, currently, you can just ask it to do that from a ChatGPT standpoint. So this is really, really cool. And then we just fill in our examples here, which is what we saw before. And then ask it for the optimal prompt. So this is going to be the output that we're actually going to use for the next model then. So then we create our instruction prompt. The examples is the input variable. This is all the same as we saw in the LangChain quick start. Then the instruction chain is an LLM chain with the instruction generator and then the instruction prompt as well. We run it and then we add an iteration and flush it. So then essentially what this does is, given this prompt and all of the dynamic examples, it will generate the QA bot for us. Then, given these instructions, and this is the second part, so we first fill in the instructions, we add some examples that I pulled from the original LangChain prompt, and then we fill in the question as well as any of the summaries from our documentation, right? So we're combining this prompt template with the input variables, summaries, questions, and instructions, and then we create a QA chain that is pre-built by LangChain. LangChain has this VectorDB QA with sources chain that we can use, right? And then we can just set the combined prompt to be our own prompt, to be the prompt that we made right here. And what that will do is it will essentially manage the database for you. It will get all of the most relevant pieces of information, most relevant pieces of documentation, and actually fill that in to the QA bot's prompt, right? And this is actually all that happens, right? So now we are doing this stuff. It will generate the answers, and all of the answers will be added into the LangChain pieces of like text, right? The text boxes. So we get here again. So as you can see now, please provide a detailed and accurate answer to the question at hand, including relevant sources to support your answer. If you're uncertain about the answer, please state that explicitly. Make sure to format your sources as source semicolon for better readability. So it already took into account our previous feedback, given that we just pressed submit, right? And so now I can see, how do I create ClearML credentials? It still didn't do that very well, right? So, but in this time, the question 0 is wrong because it didn't get the sources formatting correctly. But this time, question 1 actually does, right? Sources, there we go. Same thing with can you clone entire project? All the sources are handled correctly. Same with the questions that are following as well, right? So this is super, super interesting. You can see that immediately our feedback had impact. And now any person can start optimizing this chain. So I hope you found this interesting. I hope you learned something today. Please leave a comment in what you would like to see in the future. If you want to do more LangChain projects, if you want to dive deeper into it, there is always the code that is available. So I'll add a GitHub link there as well. And if you have any questions, just jump on our forum in Slack. So I'll see you there. Hope you found it interesting, and see you in the next video.